Hello, I'm Paul Beckwith, and of course, this is Shackleton the Explorer. Just want to make sure my mic is on. I think it is, it's fine. So, if we look more alert than usual, I'm talking about the two of us, it's because we just went for a little walk outside and it's about minus 20, minus 25 degrees Celsius with wind chill. Yeah, I was just wearing this sweater. Just went for a little, just for 5 or 10 minutes, sort of around the neighborhood. And this guy wasn't is wearing what he's wearing. So Shackleton the Explorer. So what I want to talk about in this video is urban conflagrations, urban fires, and they're not really wildfires. They're in a class of themselves. I'm talking about fires that burn so hot and the winds are so fierce that pretty much every structure gets completely destroyed by the fire. And you can try to protect these structures. You can have lots of water wet the roofs and have water systems around them, and the fire can still burn them down, because it turned out that in the Colorado fire that just occurred just before New Year's, the winds reached 100 miles per hour, and of course that carried embers and blasted embers against houses. Like, think of sandblasting a place, only this is hot burning embers, and these embers went into ventilation grills, and they went in like exhaust vents in houses. They went under doors, through windows, if any cracks, if the windows were slightly open, right inside to the houses. And often these houses started to burn from the inside out. And devastation was almost total in some regions. So let me just turn my camera here. So we've got completely different behavior than what we had before. Okay, so these images here were actually tweeted out, and the woman who tweeted these out is a climate scientist at NOAA, the National Oceanographic and Atmospheric Administration. In these people living in this neighborhood, lots of them are scientists and meteorologists working at NOAA, the University of Colorado, Denver, and risk assessment places. A lot of them are doing climate work. And the woman who owns this house right here that is left standing was actually sending out tweets as this fire was going on. She was pretty sure she had lost her house, and luckily it survived. So, why did all of these are all the footprints of all houses in the neighborhood. Everything's completely gone. As far as I can see in this picture, this is the only house that survived. So how does a fire take out all of these structures? And the fire burned for everything was gone in a matter of hours, pretty much. I think the fire then spread to other urban neighborhoods, and it went for about 8 hours with 80 to 90 to 100 mile per hour winds, just destroying everything. So that kind of brings to mind the you don't see this very often. We haven't seen this very often since World War II. We did see it in Paradise, California in 2018, and we also saw a similar thing in Lytton, British Columbia in 2021. And then, of course, this fire in Colorado, which was burning on December 30th, 2021. So, the last couple days of the year. I'll just show you a couple other of the images that were tweeted out. Total devastation, but you can still see, many of the trees appeared to be unharmed, unless the tree is directly downwind of a house, of course, and then the flames with the 100-mile-an-hour winds blowing through this region, the flames are, of course, spreading from house to house, getting any trees in the way. But any trees that are upwind, these trees look actually unharmed in the pictures. Like right here, for example, look at this tree. It's not burned. These ones here are burned, but you've got these trees here which managed to survive. Fire goes through a particular region extremely quickly. You can still see small fires here in this image. And there's another image, with the fire burning here and the trees still there. But total devastation. So this was tweeted out here. Okay, I'll just show you. So let me start from the beginning and I'll come back to this. Okay, so this is my website, paulbeckwith.net. It's been a while since the last post, and I haven't done too many videos. I'm going to start up my videos again because there's so much to talk about. Start them up on a more regular basis, try for every couple days. Of course, we can get brutally cold outbreaks in our climate casino, and the jet streams becoming wavier with the ridges going into the far north and the troughs going into the far south. Those ridges can carry warm air right up to the Arctic, the North Pole, and the troughs carry cold air deep south. So temperature is less a function of latitude, but more a function of where the jet stream pattern that's being established and how persistent it is. And if it's not very persistent, then we get this weather whiplashing from one state to another state back to the initial state. Okay, so just to get Ottawa, we reached above 0 degrees Celsius, above freezing point, just yesterday, I guess, and then today it was very cold, and tomorrow I think the high is about minus 24, minus 25 Celsius, or that's a low rather, and then the high is about minus 16 or minus 18 Celsius, with heavy high winds, so lots of wind chill factor going on. So we're getting those sort of outbreaks, as they're all part of extreme weather. The Arctic is warming because it's darker, the albedo is lower, it's absorbing more sunlight, but also when you get a jet stream, extremely wavy and broken, the cold air can spill right out of the Arctic, and of course it's replaced by warmer air that goes back up into the Arctic. So we're getting both of those things happening. So please consider donating at my PayPal account. I do rely on your donations to keep doing my work independent of any organization, so I can say whatever the hell I want, basically. I can give you the utter and absolute truth as I see it. And speculation, hypothesis, based on my analysis of what's happening, as to how quickly things will happen in the future. Okay, so this is my YouTube channel. Just Paul H. Beckwith is my on YouTube. So please subscribe to my videos, and you'll get messages when I'm posting a new video. Okay, so one thing, this person, Aaron Rigsby, he's a storm chaser, and he filmed the video. He covered this Marshall Fire, from the burning of the fire to the aftermath. So I'm going to show you parts of this video because I can't explain it in a better way than showing you parts of this video. So it's Aaron Rigsby. Okay, so here's the video, and I'll just play it for a little bit here.
New Year's Eve, a time of celebrating another year alive and cheering to new beginnings. Christmas lights still shine bright from holiday cheer and Christmas decorations for kids to enjoy. But on the morning of December 30th, 2021, the residents of Superior and Louisville, Colorado were about to have to start from the very beginning. Just before 10:30 p.m., a.m., Mountain Daylight Time, a small fire was reported at the intersection of North Foothills Highway and Middle Fork Road that was attacked quickly with no loss of property. This was, however, just the beginning of what was about to be Colorado's darkest day. Just after 11 a.m., another fire broke out at the intersections of South Foothills and Marshall Road. This fire, fueled by winds of 80 to 100 miles an hour, quickly escalated out of control and spread east towards the cities of Superior, Colorado and Louisville. Forcing an evacuation of the entire city, residents had just minutes to escape their homes and left most of their possessions behind as the fire overtook the city. The following footage is from Ground Zero as neighborhoods and businesses burned to the ground. Yeah.
Just unbelievable, the speed of those winds fanning those flames, bringing all this oxygen in and throughout these structures. And you can actually notice in the footage many of the embers that are generated from one burning structure then being carried by the wind and, of course, setting anything in their path downwind of the burning structure on fire as well. There were some businesses like a Walmart was completely destroyed, and the Walmart is a cinder block structure. Okay, so you'd think it would be able to withstand a fire and not catch fire itself, but like I said, cinders being blown 100-mile-an-hour speeds find their way into any structure and then can start the structure burning from within. And people that study wildfires say that fire has a way, and that's maybe reminiscent of hydrologists who say, water has a way, but I think the original saying, of course, was that life has a way, and that was said by the biologist in the original Jurassic Park, of course. You can see all the embers. They're coming from the house that's burning. Like snow almost. And what put the fire out eventually was a big snowfall on New Year's Day or the day after.
First light of New Year's Eve revealed what most had feared: total destruction. Nearly 1,000 homes, a shopping plaza, and a hotel were torched in the blaze, and over 130 more were damaged. Residents, desperate to know if their homes were still standing, stood in disbelief, as the only thing left were concrete basements. The first day of the new year added salt into the already deep wounds of Superior and Louisville, as a major winter storm dumped over 6 inches of snow on the burn-scarred area. With mandatory evacuation orders still in place, residents left their vehicles and began walking through the snow to see the fate of the place they called home. 24 hours sooner, and the outcome of this event could have been much different and much less devastating.
Okay. Well, it makes you almost speechless there. Okay, it makes you almost speechless. And I really want to thank Aaron Rigsby with the Colorado Storm Chasers for putting together this documentary on the Marshall Fire, on the terrible fire in Colorado. Okay, so this is where we are. Okay, on Google Earth, Superior is here, and Louisville is here, and there was another small community here. These are the places. This is the red outline here is the outline of the town, and where most of the burning occurred, and you can find the individual streets and so on where. Find the individual one where I showed you that one house remained standing. So the fire was the worst here, I believe, and also here in Louisville, and there was and Broomfield, I believe, also. Got it. So here's where it is relative to Boulder, Colorado. This is the Rocky Mountains. So the winds were very, very fierce and came down and reached 100 kilometers and miles an hour, which is 160 plus kilometers an hour. knocked over live power lines. The power lines triggered sparks, setting off the fire. The region was preconditioned by having one of their worst droughts in 150 years and extremely hot temperatures, very, very little rainfall. It was like a tinderbox. And so combined, once the fires were triggered by sparks from the downed hydro lines, the winds just fanned the flames and spread it right through from structure to structure. So horrifying. If we look at Earth Null School, what I did is I took the longitude and latitude. Remember, if you're in Google Earth and you scroll over the region, on the bottom corner here, it gives you the latitude and longitude. So then I went over to Earth Null School with those numbers, and that's the pointer here. And this is the December 30th at 9 a.m. local time. The first fire was about 10:30 or so. And this is I'm looking at the wind speed, about 2 meters above the ground, above the surface. What you can see is, you can see how the pattern changes. If I go to 250 millibar to look at the jet streams, it's right in a very strong part of the jet stream there. And if I zoom out, you can see the configuration. So you've got a ridge here, you've got a trough here, very fractured and broken and split jet stream. And here's where we are. So the winds aloft are, over 200 plus kilometers an hour. And as you go down to the surface, the winds remain very strong. As I say, they were coming downslope winds from the Rockies, and it caused all this devastation. Let's go back to the surface, and here's where we are, and you can see the surface winds as we go. This is now 11 o'clock, 12 o'clock, 1 o'clock. So strong winds. But, there's strong winds in many other places. It was just unlucky. It knocked over power lines and triggered the fire in this region. So, like I say, we're getting more weather weirding, weather wilding, and weather whiplashing in the climate casino. I want to show you, so this is where I was getting these images, which I showed you at the beginning. But if we go through, this, I love this cartoon, 2022. The scientists are like pushing the door open and wondering, what's going to appear? What will 2022 be like? Here's a pandemic ward, people watching the fires, watching the climate disaster from inside the pandemic award. How's that for dystopia at the end of 2021? And if you haven't watched it, be sure that you watch the movie Don't Look Up. I gave a 7.5-minute interview with CBC Radio on the morning program this morning, talking about the movie and how it's a, how it's a perfect simile or, satirical comedy. It's really about climate change. It's not really about a meteor coming to the Earth, but it does it in a very clever way. Here are some images. This is a suburb of Denver. Okay, it looks like it's taken from an aircraft coming into land, and all of these fires with the 100-mile-an-hour winds just spreading it. A huge conflagration. And there's lots of images of how the fire spread here through Superior, Louisville, and there's Broomfield, this particular fire in the burn area here. This is the most destructive wildfire in state history in Colorado. The extreme fire weather behavior and rate of spread in a densely populated area in December is unprecedented and is just hard to comprehend. Okay, and there's lots of images here. This is a perfect example of a tipping point. This is St. Mary's Bay on the Bay of Fundy. No one knows for sure how long it's been like this, but it could be thousands of years. Okay, I mean, look at the, it looks like a person could just go and you look like an ant in this picture for this scale, and just push the thing right over. Okay, so the return of the urban firestorm. So this firestorm is really, really, we've had firestorms in urban areas, of course, in history, but we haven't really had them in a big way since World War II. Tokyo was firebombed, destroying huge parts of the city during the war, and also Dresden in Germany was heavily bombed and also firebombed with incendiary bombs. And then, when the structure started burning, huge convection, the hot air is rising, pulling in air more and more, feeding on itself. So once you get these things going, they pretty much destroy everything in the region that they're burning in. So that's the best article. Lots of images. Climate scientists are grappling with this because it's right in the backyard of many climate scientists. Okay, so climate scientists grapple with wildfire disaster in their backyard. Boulder County, Colorado. It's the heart of one of America's top climate science and meteorology research hubs. Some of the top minds who study how climate change is amplifying wildfire risk find themselves shaken and struggling to process what they just witnessed themselves. Okay, so the Marshall Fire, it destroyed as many as 1,000 homes, leaving thousands of others homeless after tearing through Denver's northern suburbs of Superior, Louisville, and Broomfield. 2021 was full of extreme weather events across the U.S., but this one stands out because it targeted some of the top scientists who are responsible for warning the public about growing wildfire risks and other risks from climate change. Boulder, Colorado is home to multiple NOAA labs. That's the National Oceanographic and Atmospheric Administration, as well as the National Center for Atmospheric Research, NCAR, very, very famous place, the University of Colorado, Denver, and the Center for Severe Weather Research. There's also climate intelligence firms and satellite companies located there, such as Maxar. They operate the satellites and the instrumentation on the satellites to collect lots of climate data. Researchers predicted there was going to be a downslope wind event. It's a natural occurrence along the Front Range in December, but it was tinder dry. There's lots of grass, dead grass on people's lawns, etc. And it was basically as a tinderbox. The region has seen months of record dry and warm weather, with Denver recording its latest first snowfall, for example. Average temperatures from September 1st to December 29th in Denver, 52.2 Fahrenheit, which is the second warmest in 150 years. Precipitation, less than half an inch. That's the least in 150 years of data. And snowfall, 0.3 of an inch. That's the least in 140 years of data. So the drought, the warmth, and the abundance of grasses, because there was a wet spring. So a wet spring, great for lots of vegetation growing, but then with the drought and heat, all of this vegetation, of course, died and was sitting there ready to burn off. And then we had an unusually high wind event with the gusts reaching the equivalent of Category 3 hurricane speeds, over 100 miles an hour. So with the short-term drought, the evaporative demand, soil moisture, soil's drying out, vapor pressure deficit, they were all at record or near record levels for December. Okay, so then the high winds, so some of the climate, like here's this Merit Turetsky. She was not surprised to hear reports of small grass fires breaking out in the high winds that were buffeting her home on Thursday. Then she saw the satellite and radar images, realized how dire the situation was. Climate change led to a perfectly built stack of fuels in the fireplace, ready and waiting to be burned. All it needed was a spark. The spark was from the power lines that were knocked over, live power lines, causing a spark. And basically, it's the rest is history. The place burned down. Here's somebody at the Center for Severe Weather Research. They deployed a Doppler on wheels, which is a truck basically with Doppler radar, mobile Doppler unit. It's got a rotating, highly sensitive radar, and they scanned the smoke plume and collected lots of data. They're used to deploying it to tornado outbreaks and to landfalling hurricanes. So here it was. They used it to see where the tufts of black smoke were, how quickly they built up, etc., etc. Okay, so many climate scientists, they don't earn enough money to live right in Denver, so they're living in the suburbs of Denver, and they got hammered with this fire. Okay, this is the best article that I could find on the so-called urban firestorm. Okay, this is much scarier than a wildfire. Author David Wallace Wells, you've probably heard of. He wrote a great book, The Uninhabitable Earth. Here's an image of, and look, again, it looks like a lot of the trees actually survive the ordeal. If they're not directly downwind of a burning house, what's happening is you get the embers and sparks in 100-mile-an-hour winds, but if a spark or ember lands on a tree, it just gets blown off, because of the porous canopy. Just gets blown, the embers just get blown right through, and if they don't have time to ignite the tree just survives. So I think that's basically what's been happening. So I'll just go over this article. Again, you can find this article, just Google the title in Intelligencer, but I'm going to point out the key points. So in the space of a few hours, just the day before the new year, 100+ mile-per-hour winds carried the most destructive fire in Colorado history through the suburban sprawl of greater Denver, destroying most of Louisville and Superior, forcing tens of thousands to flee, including many who had entered shopping malls from sunny skies just a few minutes before. As many as 1,000 homes destroyed. It's amazing that the death toll was so low. I think it went up a bit higher than that. By the standards of the megafires and gigafires, these are huge burning fires, burning vast areas of forest. Of the last few years, this fire was quite small, 6,000 acres all told, and it was finally poetically brought to an end by snowfall on New Year's Eve. But following the driest and second warmest fall in 150 years, the devastation was harrowingly out of proportion to its scale. Since most wildfire, it was not in wildland or forest, but this is an urban firestorm. The climate scientist Daniel Swain also lives in Boulder. Okay, so he's right in that region. It wasn't a wildfire in the forest, it was a suburban and urban fire. The Costco we all shop at, the Target we buy our kids' clothes at, all damaged, mostly destroyed. The fire jumped to big box stores and their parking lots and cars. To most Americans, perhaps the very picture of an inflammable Anthropocene. Fire finds a way. There you go. There's that quote. The way during this fire was that it carried the wind, basically. The wind carried flames and embers at hurricane force speeds for 8 straight hours, consuming football field lengths of land in seconds. Okay, so the mention was here that, a lot of fires recently, like the Camp Fire, this is the Paradise, California fire in 2018, that burned 18,000 structures, 85 deaths. It was a relatively dense community, and it was in the wildland urban interface, so basically houses in the woods. But what we saw in Colorado was different. Subdivisions, tract homes, fire just tearing through suburban environments that we've been taught to think of as safe in every way. Lots of people have been calling this a Colorado forest fire, but it's absolutely not a forest fire. It arguably started as a wildfire, mainly as a brush and grass fire with some woodland near the point of origin, but then it spread because of the 100-mile-an-hour winds into the urban regions just a matter of hours after it initiated. Okay, okay, and there's some images here, lots of videos, lots of images. I'm just going to go to some of the key parts here. 90 to 100 mile per hour wind gusts moved it into a different regime from other fires that we've seen. I mean, a lot of these structures, Costco and Target, they're cinder block buildings, and they're not going to start burning on the outside. If it's just concrete and cinder block. So what it is the embers go in through a window or a heating duct or an air exhaust vent in the building, and they start the structure on fire from inside. Okay, so here you go. I think of a Costco in a parking lot as being about as non-flammable an environment as you can imagine. The parking lot's a huge expanse of concrete. The store itself is not exactly made of wood. How does a fire actually power through that space rather than getting stopped by it? And in hydrology, people say water finds a way. In Jurassic Park, it's life finds a way. In the fire community, it's fire finds a way. And all you really need is wind fanning the flames. Okay, so there's a sea of ash and embers, literally a sea flying around. Okay, there's other videos of just landscaping, the brown grass, the trees that are in the mediums, they all just ignited from this ember storm, and the big box stores, if you're under constant assault from this ember attack, 90 mile an hour or 100 mile an hour sea of embers just constantly hitting the building, it's eventually going to find the gaps. It's going to find the air vent. It's going to find a gap between the ceiling and the roof. It finds its way in, the embers get hold, and then there's fire inside the building. So a lot of the homes that burn in these kind of fires don't burn from the outside in. They actually burn from the inside out because embers have blown inside, started a house fire that then burns from the inside out. Okay, so that's basically what's happening. Yeah, you can read more and more. I mean, the vegetation in between the buildings acts as a kind of wick. It isn't the main thing that's burning. Okay, Oakland Hills fires in 1990s, similar. Okay, all 20 of the largest wildfires in recorded Colorado history have taken part in the last 20 years. Okay, so just horrifying. There's not much you can do when the winds are 80, 90, or 100 mile an hour. There's not much firefighting you can do, which is something I think most Americans, most people around the world still don't appreciate about these fires. The winds were so strong that some of the flames that this person saw were actually self-extinguishing for brief periods, being blown out by a candle. Of course, the net effect was very rapid spread, but during the most extreme gusts, the fire would lay down. You couldn't see flames. It was just smoldering, right? It would lie flat against the ground. And then there'd be a low in between gusts, and it would flare up and then jump. And then the next gust would bring those burning embers and throw them hundreds of yards in advance, right? And you get this highly nonlinear spread, okay? A lot of people were saying, why didn't they put water on it? This is an incredible mismatch of scale. There's a lot of people who don't live in the West who still think that wildfires are like the size of somebody's backyard or something. No, these things get enormous, and of course, once they're burning, the huge convective updraft brings embers very high, can spread them very, very far, carries up very large embers like chunks of flaming material, and then can toss them, miles and miles away to trigger other fires. Okay, and you saw the image from the plane of the overall region and spots here. That's the case, I think, of those embers being spread. Like the fire would be triggered where the power line went off, and then it would go in an area, embers would shoot up to the sky, come down in other areas like little fire bombs, little incendiary bombs. Okay, so, and these winds were so strong, this was a reservoir at 2 p.m., and you can see the the water is actually flying out of the reservoir. The winds were so strong. Okay, so it was extraordinary, and we have to think about, are there any ways that we can harden people's houses, etc., etc. This is a perimeter of the Marshall Fire that burned the 6,000 acres, Marshall Lake, in the regions around. Okay, lots of people underestimate risk. Of course they do. Risks from climate change. And then they talk about British Columbia and the people there. It's interesting. At the end, they talk about, well, where do you live? Like, how do you escape from the risk, or how do you minimize it? Where do you live? And you're never going to find a place that's perfect, right? There's pros and cons at different places. There's some places you don't want to live, like right on a coastline or on a floodplain, and things like that. Okay, so anyway, I just want to end up by showing you, to find out more about these different fires. The Paradise Fire, which was the deadliest and most destructive wildfire in California's history, most expensive natural disaster in the world in 2018 in terms of insured losses. There's all kinds of information on that. And I was on Earth Null School looking at particulates, and I could actually see, go back and see the points where those fires, this fire was triggered. And again, it was power lines that were knocked over, live power lines, causing sparks, and then destroying Paradise, California. So lots of information there in 2018. Then, of course, in June of 2021, Lytton in British Columbia, the town was completely burned down. There were record heat waves. Temperatures reached 49.6 degrees Celsius. This is interior British Columbia in Canada. Highest temperature ever recorded in Canada. Then there was winds up to 70 kilometers an hour, 44 miles per hour, pushing the fire along. Propane tanks exploded, and it just spread and spread and spread and took out the town of Lytton. And then, of course, I said that this reminds me of firebombing. So here's the bombing of Tokyo, firebombing air raids by the United States Air Force during the Pacific campaigns, Operation Meeting House on the night of 9th to 10th of March 1945. It's the single most destructive bombing raid in human history. Of central Tokyo, 16 square miles, 41 square kilometers, or 10,000 acres, were destroyed, leaving an estimated 100,000 civilians dead and over 1 million homeless. And it was actually a lot, the casualties were a lot higher. Both sides tried to downplay the casualties. And it was, it was just incredible. Incendiaries dropped, just a maelstrom. People, here's a woman who was carrying a child on her back and, completely charred, charred remains of civilians, right? It was just a horrible situation. The highest density of any industrial city in the world, firefighting measures ludicrously inadequate to the task, wooden buildings, 15.8 square miles destroyed on a night when fierce winds whipped the flames and walls of fire, blocked tens of thousands fleeing for their lives. Okay, so just terrible. And then, of course, the firebombing in Dresden. Okay, in Dresden, bombing of Dresden in World War II, 4 raids between 13th to the 15th of February. And there's a quote here I wanted to read. The attacks, where is it? Here we go. We saw terrible things: cremated adults shrunk to the size of small children, pieces of arms and legs, dead people, whole families burnt to death. Burning people ran to and fro, burnt couches filled with civilian refugees, dead rescuers and soldiers, many calling and looking for their children and families. Fire everywhere fire. And all the time the hot wind of the firestorm threw people back into the burning houses they were trying to escape from. I cannot forget these terrible details. I can never forget them. This is from Lothar Metzger, a survivor. So just again, human-caused urban firestorms in World War II, and now we're getting them in 2018, the Paradise Fire, 2021, the Lytton, British Columbia fire, and now the fire in the outskirts of Boulder, Colorado. Okay, well, thank you for listening. And how does one protect houses? A metal roof would help. Something that's fireproof on the outside of the building, siding, would help. All the windows would have to be closed. The vents would have to be closed off. And, water sprinkler systems both within and external to the house. And maybe a water supply and pumps and electrical generators in the basement, because you can't count on the water supply working when this type of, fire sweeps through a city. And I've seen actually some images of somebody having this enormous tarp with a aluminized reflective coating on the outside of the tarp to reflect away heat, and they covered their entire house with this to save their house from a wildfire. But how much do these things cost, and would people have time to deploy them, etc., etc.? Anyway, thank you for listening, and please remember to subscribe to my website, paulbeckwith.net. Consider donating with PayPal to support my research and analysis and videos. And I also have a PayPal, or I also have a Patreon account, so you could just go to search for my name on Patreon, and that route also works for supporting my work. Okay, thank you everybody for listening, and I'll be back soon to talk. I'm not sure about my next topic, maybe some of the things that are going on in British Columbia. It doesn't look good right now for British Columbia. Another atmospheric river seems to be heading there over the next few days. Let me see if I can find the here we go. By the way, yes. So my CBC interview this morning on the recent Don't Look Up movie, there's a link here. I posted a link on my Twitter, Ottawa Morning. Climate expert reviews Don't Look Up. And also there was something else I wanted to show you if I can find it. Facebook Messenger. Here we go. Yeah, so this is what we can expect for rainfall accumulation. Today's Monday, January 10th. This is through Thursday. This is in the Vancouver area. There's Vancouver there. 200 plus millimeters. So this is 200, this is 300 plus, this is 400 millimeters in some of these areas. Okay, so 2 to 3 to 400 millimeters in widespread areas. And if you look at the snow on the ground today, January 10th, this is the amount of snow in various regions. So if we get rain on snow up in these elevated regions, then we can get lots of roads washed out. And if this is a long duration atmospheric river event, we can get lots of grief once again for British Columbia. And they've had exceptionally cold conditions for the region recently. They've had this cold outbreak, and I talked in the last video about cold outbreaks in a warming world. And they're not getting a break there. Okay, well, thank you very much for listening, and I'll see you soon in my next video. Bye for now.